Hey folks, thanks for joining me today here. My name is Kapil, and I'm a platform security engineer with ESnet, Energy Sciences Network. I work on Kubernetes networking, Kubernetes security, security automation tooling, and anything DevSecOps related. I'm also a recovering network engineer and an OpenStack survivor, so that says something, right? All right. So what is ESnet real quick? So ESnet is basically the high-performance wide area network that essentially serves as the data circulatory system for U.S. Department of Energy, and that interconnects all the U.S. national labs and user facilities. So think of Los Alamos National Lab, Sandia National Lab, Lawrence Berkeley National Lab, Livermore, all those, and that interconnects all these national labs together. It's a dedicated high-speed network, and so ESnet's vision is that scientific progress will be completely unconstrained by geography. Physical location of instruments, people, computational resources, and data shouldn't matter. And by instruments, I'm talking about things like particle accelerators, which are relevant to physicists, right? Or telescopes, like big telescopes that are relevant to astronomers. And so technically, ESnet is part of a Lawrence Berkeley National Lab. At Berkeley Lab, we have a track record, a long history of contributing to open source projects, especially around networking and security world. So if in case you're wondering, the BPF and eBPF originated from Lawrence Berkeley National Lab. If you've ever heard of Zeek, intrusion detection system, that also came from LBNL. IPv3 network performance measuring tool, that is also currently maintained by one of the ESnet developers. All in all, that's to say networking is our bread and butter. So all right, jumping onto Kubernetes, what's the motivation for Kubernetes and IPv6 in our use case, right? So at ESnet, we use K8s to serve a lot of homegrown and vended applications that manage the network, that manage our wide area network, right? And as we know, modern applications are microservices, containerized, and whatnot, right? So the ultimate aim over here for us was to reduce VM sprawl. We used to have one VM for one containerized app, and so on, and then came the OMB 2107 mandate. And basically what that does is this government mandate sets aggressive goals and timelines for federal agencies to phase out IPv4 usage in the federal government, right? And then we have some of our senior engineers at ESnet who are involved in that V4 to V6 transition and coordinating that effort between federal agencies and such, which means we need to eat our own dog food, right? And sometimes that involves stepping into uncharted territory like Kubernetes IPv6, right? And making it easier for others to follow, right? All right, so technically we started our journey with dual stack, and moving on to IPv6 only Kubernetes on-prem has been quite the journey for us. And so in the series of next slides, I'm going to share what our experience has been, what mistakes we made, what we tried, what assumptions went into those, what worked, what didn't work, what we learned, et cetera, et cetera. All right, so we use K3s. We don't run a massive data center or anything like that. For our small scale use case, K3s is a distribution that just works out of the box, works really well, honestly. So basically what we did was, so we tried to bootstrap K3s in an IPv6 only environment. And it's just a one-liner, right? From at least that's how it's advertised. It's just a one-liner, go run it. And technically it worked in my home lab, but it was a one-liner, right? So we had node-to-node connectivity. We verified we could reach Docker Hub to pull images, et cetera, et cetera. Then we tried installing K3s. Well, that failed. Why did that fail? Well, so it turns out the installer script that K3s, that you download, it downloads from a GitHub repository. All right, that's in the releases page. And now before you jump out of your seats and say it was DNS, no, it was not DNS. It was DNS 64. All right? So technically, what we learned over here is that there are some underlay infrastructure requirements that need to be met. You have to have node-to-node connectivity. You have to have node-to-node to external registries, right? Connectivity from your nodes to external registries. So when you run kubelet calls a CRI. CRI can pull the container images and provide it to your to Kubernetes, essentially, to create pods and stuff. So DNS address synthesis, DNS 64 address synthesis, that's a requirement. And what does that look like? So technically we should have received this, right? 64:FF9B: something, /96. The last 32 bits are the IPv4 encoded addresses in that string. So, but that 64:FF9B address, that's non-routable on the global internet, right? So how do we connect to GitHub then? Now you need NAT64 gateway. All right. So how do you get NAT64 gateway now? Well, turns out you can actually use Cilium as a standalone NAT64 gateway, in case you didn't know about this. So while it's not official in the official Cilium docs, you just copy this one-line string. Well, not technically not one-line string, but you get the idea. And you actually just run this as a standalone Docker container, and it works. I've been running this in my home lab for over a year now. And actually, I even wrote a blog post about it. And huge shout out to Daniel Borkman from Isovalent, who actually helped me get it working with the Cilium 1.18 release. Another fun fact that which I learned last year when I was talking to Thomas Graf with Isovalent is when Cilium was originally written, it was written with IPv6 first in mind. IPv4 support was added later after the fact. All right. So now we've got DNS64 taken care of, NAT64 taken care of. Now we're able to download our K3s distribution, favorite Kubernetes distribution, whatever, right? So next step is to figure out how do you actually install K3s properly, right? So we have, at bare minimum, you need to have installed CNI to get a functional cluster. All right. In case the last meme wasn't clear, pro tip, don't simply rely on defaults. All right, that's the point I'm trying to make over here. There are certain things that you have to keep in mind, like documentation around config bits to deploy IPv6 only Kubernetes is actually quite thin, and that's not just specific to Cilium or anything. It's just in general with CNCF ecosystem. If you go around looking for IPv6 only, you're mostly on your own. So like most of it is DIY, or go read GitHub issues or go to GitHub comments in the source code. There can be too many moving parts. And so there needs, and especially if you're doing it on-prem, you have to do some planning with respect to network design, and so now you're responsible for end-to-end traffic flow. Some architectural design choices can tend to be one-time decisions, apparently. For example, choosing an IPAM mode or choosing a routing mode. Well, I mean, those things, and you need to do some address planning for pods and services, make sure those are non-overlapping, right? And what if one day you wake up and your boss says, well, we are going to do cluster mesh now, between multiple clusters. Well, congratulations, because cluster mesh requires you to have unique IP addresses between multiple clusters. So now you have to go redo the whole thing. Ask me how I know. All right. So fair warning, when we were basically at Cilium 1.15 at the time we started investigating IPv6 only with Kubernetes. And so cluster pool with native routing at the time seemed like the most obvious and the stable choice, right? And so in this scenario, what do we have here? Let's say we have 2 nodes, just as an example, right? And we have 2 nodes. We've got 3 separate applications, green, blue, purple, right? And then you have the Cilium operator. You basically configure the Cilium operator as a /56, let's just say, for example. And you configure the mask size, and that hands out a /64 prefix to each node. But that also means any application, any pods that get created on those nodes will basically come out of that /64 that's delegated to the node, right? So there is not a whole lot of flexibility, but technically speaking, this works, right? All right, so we have this great infrastructure now, forward-looking. We've got IPv6 working. Let's go and try to deploy an app. What happens? All right, to deploy an app, okay, so we've got that. We've got a service created. We've got some endpoints over here, right? Deploying, and this application behind the scenes, by the way, is just a simple Python-based, HTTP server that's running over there. So technically, the application deployment worked. But when I tried to launch a Netshoot pod, try to connect to the application, that didn't work. Well, why is that? Interesting. Looking at Hubble logs. Well, Hubble logs say connection gets reset. Well, that's interesting, all right. Now let's go launch a debug container and see it's binding to an IPv4 based socket. Why is that? Well, turns out the developer decided to hard-code IPv4 address in their source code, all right? Because from the developer's point of view, hey, it works on my machine, right? So, the point that I'm trying to make over here with this is that this is actually a common problem. Is even though you can provide as much as a beautiful infrastructure, have IPv6 over there, have all sorts of crazy bells and whistles, sometimes it boils down to the most basic things that we don't even think about. Is someone hard-coded something in their source code, someone hard-coded something in their config file, in their Helm chart, in their Docker file, anywhere. All right. So we said, but that's not the end of our problems. With IPv6 native routing cluster pool IPAM, that's the combination we went with, right? Let's look at a little more in-depth into this from a design point of view. So if you look at ingress, here's what happens. Here you have application green that has multiple replicas and stuff, and so now you try to expose this via gateway API, and so what we do is we expose this via gateway API, and in the backend, it creates a load balancer type object. And then we advertise that WIP through BGP, Cilium's BGP control plane. And so technically, from a firewall's point of view, the ingress path is clean because we now have one predictable IPv6 address for an application, right? That's fine. For egress, not so much, all right? That becomes a little murky, especially in a multi-tenant environment, right? Where you have like multiple applications running on in the cluster. You kind of want to provide some like isolation, defense, and depth, so that you're not only relying on Kubernetes network policies per se. You also want to have, you also want to be able to integrate your existing cloud-native applications into your on-prem environment security, larger security architecture, essentially, right? That was our goal to begin with. Oops. So with pod IPv6 addresses, node addresses, there is no predictability where the pod gets scheduled. All of those can change, right? And so firewall doesn't know which pod v6 address is associated with which applications. So those are the kind of challenges with egress. Again, this is in Cilium 1.15, remember that, right? So basically, there was a reckoning in the team at this point, right? Which is running, v6 only Kubernetes cluster is like means to an end. Essentially, the end goal here is to be able to run our applications which serve our actual needs, right? Serve our actual business needs. So we can't route IPv4, and that remains a hard requirement for us. But so basically our solution at the time was, well, we can get a little creative around the network design, right? And so what we ended up doing was we basically added a second interface to our nodes, right? And basically the ETH0 interface now serves as the interface for north-south traffic. ETH1 serves as the interface for east-west traffic. And the way we manage predictability in this, architecture, essentially is we used advertise address, node address, like the config bits typically that you use, in your Kubernetes configuration. When you bootstrap the node, have it join the cluster, so it would join the cluster over ETH1 interface. But when it comes to serving the application, it would serve the application over ETH0 interface. So that's where our north-south traffic would be, right? But again, how do you get egress solved in this case? And so there are still some warts in this. It's far from perfect, and it's anything but perfect, in fact. So technically, for intra-cluster traffic, nodes would join, and so the interface is dual stacked. ETH1 interface was dual stacked. It was not non-routed, to be clear. But that meant we could use Cilium's default VXLAN tunnel routing mode, right? And the limitation up until 1.16, 1.17, right, was that, well, you have to have dual stack because IPv6 only underlay was not supported. Does this combination work? Yes, it does work. Pods get dual stack addresses, but of course it comes with its own set of problems. Problems like, well, you're masquerading now, so that makes it difficult for traditional security teams to correlate logs back to the original source application, right? So what if your security teams run, which our security team does run, we have a pretty good Zeek intrusion detection, like Zeek perimeter-based IDS, deployment on-prem that sits between the firewall and the router, right? So it's tapping all the traffic. And now, so basically the way we get around that egress problem is why we pin down workloads to specific nodes using node selector to get predictable egress v6 address. Far from ideal, but it works. But again, we made these decisions knowing the fact that in 1.18 things are going to change. Future looks bright, right? So by this time, actually, we had a pretty clear idea of what we really wanted to see in a truly IPv6 only K8s cluster, right? By minimizing masquerading, we wanted to retain end-to-end visibility, right, and simplify troubleshooting across the cluster. And for us, true microsegmentation would imply that each application must be placed in its own /64 subnet, right? And this enables fine-grained policy enforcement and allows us to isolate workloads at the cluster, both at the cluster level as well as at the network layer, right? So defense in depth. And of course, you can apply Kubernetes network policies, egress network policies, et cetera, if you want more fine-grained stuff. The point here is that each application gets placed in its own namespace, and each namespace must be allocated in its own. Each namespace must get its own /64, right? So now so if you look at any modern application these days, what are the components that come with a modern application? You've got like what front end, back end. You got database, you got message queues, you got like cache, you got like all sorts of stuff, right? So technically, one modern application can have like what 5, 7 components. So yeah, we just put one modern application like inside its own /64. There's no shortage of IPv6 addresses last I checked. So all right, great, problem solved. But how do we get there, right? Okay, so everything I talked about so far was tested on Cilium 1.16, 1.17, right? With like, but 1.18 brings significant improvements for like IPv6 only support with respect to multi-pool IPAM. And multi-pool, if I read the GitHub commits correctly, like it goes officially GA in 1.19, like technically, like according to the release notes. So what does that mean for IPv6 only Kubernetes then? All right, what that means is, with 1.18, actually, you can actually rely on defaults. Oh, wait, I may have misspoken. Multipool goes officially GA in 1.19, not in 1.18. So with Cilium 1.18, actually, you no longer need to be an IPv6 or networking wizard to run v6-only clusters. Why does that matter? Well, that matters because now, finally, the developer, it makes it easier for people to get started with IPv6 only Kubernetes and be able to test their applications to see whether their applications actually work in IPv6 only world or not, right? That was the biggest barrier. So now again, like with these configs, with these Helm values, you still need to have like egress gateway over there because you're going to run into masquerading. Now again, I wouldn't want to deploy this in production because we would need an egress gateway and masquerade all over it, and that goes against the design philosophy that I just talked about. So, holy grail of Kubernetes networking. I would consider multi-pool IPAM officially reaching its stable status in 1.19 to be like the holy grail of K8s networking, where one application, one namespace, we can finally assign /64 prefix per namespace, and then pod addresses get assigned out of this prefix. Clean ingress and egress, no masquerading, and multi-pool gives us just that. So what does that look like? In action, here's what that looks like, which is, so you have application green, application purple, and so Cilium operator will like delegate a subset of CIDR pool, that is mask size, to each node, which requests it, right? And so, so then, like for example, in the diagram, as you can see, like you have green pool, you've got like purple pool, right? And so we're saying like, here's a /64 dedicated for the green application. Here's a /64 dedicated for the purple application. Each node will get a /80 out of it, right? Now, if you're wondering, well, why is there /80? Because there exists a bitmap limitation in CIDR set implementation right now. If you go under like what package IPAM CIDR set, you can go look at that. All right. So, what are the key takeaways, if I may? At the bare minimum, your underlying network must support DNS64, NAT64, and then you have to do like basic IPv6 address planning and whatnot, right? And then BGP if you want to get like into multi-pool IPAM native routing so that you can advertise PodCIDR routes and such to be able to fully squeeze the benefits that Cilium has to offer. Now, the cluster network side, you have to do like PodCIDR, ServiceCIDR, native routing, overlay, like these all have trade-offs and such. Ingress versus egress, what would that look like? Beware of hard-coded IPv4 addresses, right? So your Docker file, config files, Helm charts, applications, source code, like these things tend to people tend to hard-code v4 address because it's convenient, but then it just becomes more tech debt, and yeah. And then you have to be able to when in doubt, use Hubble for troubleshooting. I don't know what I would do without Hubble, honestly. And yeah, that basically comes to an end where I would say, like, I've been actually writing a blog series about this, about like how to do Kubernetes with IPv6 only. The next post I have is specifically on multi-pool IPAM and native routing. So yeah, check it out if that's something that, if you're interested in this space, come talk to me. Thank you. Questions?
Does the multi-pool, does that allow you to say, create some selector labels and any,
Does the multi-pool allow you to use like a selector label so that you wouldn't be limited by namespace or anything? I could say, hey, these pods will come from this pool.
Yes, yes. So for our implementation, we are just saying, hey, just use the namespace selector. But yes, you can actually do that, I believe. Like you can go and say, use these set of labels, select based on these set of labels, and that will select like a set of pods. They get a pool out of that multi-pool IPAM, I guess. Yep.
And that's production ready in 119?
Yes, I mean, it goes GA in 119. Yeah, but like, based on my conversation with ISO Valiant engineers, now correct me if I'm wrong, but like it's near production ready in 1.18 as well. Like it's relatively stable.
So it's available in 118?
It's available in 1.18. I mean, the multi-pool came out in 1.14, I think. Yeah.
Oh, okay.
Yes.
Excuse me. I noticed you did native routing with the Cilium BGP control plane, right? Did you get a chance to try out with, before that feature came out, there was a way to do it with kube router as well as BERT. Did you try it out, and can you share the experience?
We started using Cilium actually when in 1.14. And in 1.14, we were experimenting with, let's just say, Cilium with 1.14, right? And by the time we hit production, actually like deployed something, 1.15, and so at that point, Cilium's BGP control plane is already out, so we just use that. There's no reason to use the kube router or like use a FRR or anything underneath, yeah. Yeah.
For IPv6, do you actually need the /64, or can you use a smaller range?
Well, where's that question coming from? Okay.
Yeah. I was just wondering if you could use a smaller range, because using a /64 and having septillions of addresses seems like a waste of address space. I understand there's a lot, but at the same time, that's the same mindset that started with IPv4 and how we ran out.
So there's actually RFCs written specifically on why you shouldn't use smaller ranges and why you should use /64. I actually mentioned a couple of those in my slides, but long story short, if you think from a router's perspective, right? If you think from a router's perspective, you're now storing, let's say, a /104, a bunch of like all sorts of like different like prefixes and such. You're actually using more TCAM space, which is very limited. That's the memory in the hardware, compared to just using a /64, right? Which is where you define a clean boundary that's specific to a standard, right? And so that makes it easier for the TCAM to like summarize, do address summarization, and be able to store that in TCAM for faster lookups and such, if that makes sense. So like from a quick overview, like from a high level overview, yes, I agree with you. Like and it looks as if like we're wasting bazillion addresses. It makes no sense. Like /64 of the entire internet would be great. Yeah, right. But from a configuration management point of view, from a hardware resources management point of view, /64 is the cleanest boundary you're going to get per application.
Hey,
yes.
Could you talk about your experience dealing with network observability using Cilium? How do you find it easy? Could you share your experience with that? Because that's some challenges we have right now. So I just want to really pitch in Cilium to my organization. So
let me say it this way. Like, without Hubble, I don't know how we would be able to troubleshoot any problem within with Cilium or with Kubernetes. Like, Hubble was actually one of the biggest drivers why we chose Kubernetes, honestly.
They go in deep, and the packet capture, right? I don't want to heavily invest on top of a rack observability tool like NetScout. And I don't think in K8s world, they give me the exact thing. In this modern world, the pod traffic is more important, right? That exactly tell you what goes wrong, right? Does Cilium and Hubble help me with that? Is that your experience?
Yes, like Hubble, the amount of flows, amount of logs we get from Hubble, let me put it this way, like as in the CPU utilization, memory utilization, none of that is a concern. The concern over there is our CM cannot handle those logs. Like it's so much. Yeah.
One more question. The hard-coded IPv4 that you talked about, how do you identify that, and how did you actually, your business, like in your organization, how do you kind of motivate your developers to kind of move over to that?
So That's a good question.
Because our half of the world runs in IPv4, and I'm
Yeah.
pretty sure we'll get into that same thing.
Yes, so that is a challenging problem that we continue to run, but what we have done is especially 1.18, right, it makes it really easy to actually let developers use remote development environments, right? So what we do is we give them remote development environment, and that remote development environment has like IPv6 only, development environment for them. Like, so all their software is already, like, all their development, all the things they need for doing their development work is available in that remote development environment. And so over there, they can go do the development work, see if their application works in a native environment where it's going to run, right? And that's how they can test it. But if you want to test locally, like if you want to test if I'm doing development locally, and if I want to test whether my application works in a v6 only environment or not, right? So actually, I wrote a blog post about it as well, which is like, if you want to run kind on macOS, like you can go check out the QR code for my blog, and if you want to run kind cluster on macOS with v6 only, you can do that. Oh, okay, I'm out.
Yeah, thank you.
Thank you.